Okay. Pay very, very, very close attention to this. In fact, Michaela, can you go get me some graph paper? I'm going to need about 3 or 4 pieces. Thank you.
Welcome.
All right. We're learning about slopes. So tomorrow will be your quiz, and then Thursday we will do 9.6, and then Friday you will start a review. Monday we'll probably do 9.8. I will probably start another lesson on Monday while we're in the middle of reviewing too. Okay, I got to get this part of the chapter done. It's a very important chapter. Okay, slopes. All right, guys, see all these posters back here? Even if you can't, like Whit, you guys are back there, you know what I'm talking about. These things, they look like this. Okay, these are slopes. These are linear lines, equations, lines. And a slope is exactly what you would think, like a mountain, okay, like a ski slope, right? A ski slope. So this is a slope. This pin is sloping. This pin is still sloping. But if I had the pin like this, is it sloping? No, it is not. No. If I had it going like up and down, so I'm measuring with this line, there's no slope there. But if I were to tilt it just a little bit, there's a slope. Sloping, sloping, sloping. Do we understand slopes?
Yes.
Okay, slopes. All right. It's the steepness of a line. Steepness of a line. Pretend the pin's a line. Think of the side of a mountain. Mountains in Colorado. It is constant. Meaning it doesn't stop. Lines go on and on and on and on and on, right? Well, so does the slope. The slope, no matter if it's right here, the slope right here, and the slope right here are the same. It's constant. No matter where you are on that line, it is constantly the same. It is the ratio of vertical change, vertical change to horizontal change from one point to another. So the first two, steepness of a line, that's constant, easy to comprehend. But it's the ratio of vertical change to horizontal change from one point to another. Okay, let me explain what that means. First of all, ratio. What does that look like?
A fraction.
Bingo. It looks like a fraction. Very good. Vertical change to horizontal change from one point to another. I'll explain that one to you in just a minute. But the key word you do need to remember is ratio. Vertical change, that's going to be your rise. Horizontal, so that says rise up there. Horizontal is your run. And that I'll explain that to you in just a minute. I'm going to call this the formula for a slope. It's rise over run. By the time I'm done with you, you will be saying this in your sleep. Rise over run. Rise over run. Algebra 1 students, every once in a while they get those two switched. They get them confused. You've got to have this embedded in your head. Rise over run. Now, kind of like PEMDAS, you know how they changed it to GEMDAS because parentheses was confusing, or you know how like in PEMDAS you have multiplication and division, and because M comes before D, some kids think you have to multiply before you divide, and really they have equal billing. You just work left to right. Well, a lot of people think because this word says rise, you only go up, you rise. But that's not necessarily true. That's why they say vertical change over horizontal change. The top number is your vertical change. And that's going up and down. Your bottom number is going to be your horizontal change. That's going left to right. I have another question for you. On Cartesian plane, on the Cartesian plane, which axis is vertical?
Y.
Y. It's going to be your Y. So then your horizontal is your X axis. All right. If line, and if you're looking from left to right, goes up to right. If your line looks like this, the slope is positive. Now I'm going to tell y'all, I have to teach this part to you right here. No one ever memorizes it, and it doesn't, it's not detrimental to learning, I will tell you that. If the line goes down to right, if you can memorize this, it will actually benefit you, but very few people ever do. Your slope is negative. And I'll explain that to you as well.
So it's basically, if the right is going up, it's positive.
Positive slope. If it's down, if it's going down like that, it's a negative
So
slope.
it's like the Y positive negatives.
Oh, well, I'll explain that to you. If you have a horizontal line, the slope is 0. If you have a vertical line, now this stuff is important, it's considered undefined. These two are kind of important. Now, keep in mind, we talked about being a ratio. This is not a fraction. It looks like 1, but it's not 1. It's a slope. Slope looks like a fraction, but it's handled very differently. You can put it in lowest terms, which you need to do, but it's still not a fraction.
understand.
What?
So isn't it like if the ride is going up on the y-axis,
It's positive.
and it's going down on the
It's
bottom?
negative. Very good.
So it's basically like if the part for the ride is going upwards, it's positive, just like the y one.
Right.
Down.
And I'll explain more of that in a minute. Okay. Make sure everyone's with us. You good, Joanne? All right. To find the slope. To find the slope. Step 1. Locate 2 points on the given line. Locate 2 points on the given line, not your Cartesian plane X and Y, but your actual graphed line. So you're going to locate 2 points on the given line. Now, put 2 stars here. Use points in crossroads. Or we call it intersections. Crosshairs, I don't care what you call them.
So basically driving.
Driving and hunting, yes. Okay, so when I say crosshairs, intersections, crossroads, I'm referring to, real quickly, do you see this line? Excuse me, Taylor, I'm the one talking. Do you see this line? Do you see where it crosses the graph right here and here and here? Do you see the lines on your graph right here and here? Do y'all see that?
Mm-hmm.
Do you see where they meet? The line crosses right there at that intersection? That's what I'm talking about. When it crosses your graph on the intersection. Right here or right here, that's not an intersection. Here's an intersection. Here's an intersection here. Do you see the intersections I'm talking about?
Mm-hmm.
Those are intersections. So you're going to find 2 places, any 2 places on the line where it crosses an intersection. And I'll show you that later.
Wouldn't that be like all of it on the line?
It depends on the line. On that particular one, yes.
Okay.
But others, not so much. So does everyone understand what crossroads and intersections are?
Kinda.
It's where the lines on the graph cross, like right here. Right here. Do you see that?
So wouldn't they on every line?
No, I'm just saying, do you understand when I
Yes.
mean intersection? It's where the lines on your graph paper cross. Do you understand that?
Mm-hmm.
Okay, that's what you need to know right now. All right, step 2. This is going to be your rise. Count up or down the number of spaces vertically between points. That's your y-axis. Step 3 is going to be your run. And I'm going to give y'all lots of examples. Count right or left the number of spaces horizontally between points. That's your x-axis. Now I'll let y'all catch up when I'm done. Place vertical rise, which is your y, over the horizontal, which is your run, or x. That's that whole ratio looking thing, your fraction. And then 5, simplify or reduce, like you would a fraction. These aren't fractions, but you will simplify as if they were. So I'll let you catch up now. You good, Cecilia? Are you sure? You got it all down? If you're still writing, keep writing. See, and make sure you can read it too. Are you done? Okay. All right, so I'm going to do some examples. You can write these on your paper if you want. Okay. I'd probably write this down. especially the notes I'm about to give you. Maybe not the graph, because the graph is going to be hard to do without graph paper. Now, I was on to y'all, I kind of got on to y'all about using rulers and stuff. Guys, you're going to have to be precise in your graphs when you draw them. And I'm very serious because we're getting into an area that if you mess up, you'll get a wrong answer. Algebra 1's finding that out. They have to keep redoing their graphs until they get it perfect. Okay, so this is the one that I was just showing y'all. You see my Cartesian plane, my X and Y axis, and my line. Okay? Similar to like the stuff that's on my posters back here. If they give you this and said find the slope, just by looking at the graph. First of all, remember the formula is rise over run. Something that's very important that you need to write in your notes. If you go up or right, it's positive.
So up or right?
If you go up, it's positive. If you go right, it's positive. If you go down or left, it's negative. You need to know that. If you go up or right, it's positive. If you go down or left, it's negative. If you go up, it's positive. If you go right, it's positive. If you go down at all, it's going to be negative number. If you go left, you're going to have a negative number. Does everyone have this? Okay, so let's go back over here. We have rise over run. Now, I said to find two places on your line that are in the crosshairs or the intersection or the crossroads. I'm going to choose two random ones. Okay? Let's say this right here and this right here. Okay? Now there's a lot of others on this line. Y'all can see those, but I'm just choosing that right now. Now, our rise is our up and down. If I start right here, and watch what I do, guys, I've got to get from here to here, and you can go only up, down, side to side. So if I go take this route, and I encourage my students to do this. See my little map to get to that dot? I went up how many places?
2.
That's right. Do y'all see that? I went up 2 places. Do y'all see that? And then I went right how many places?
2.
So are those positive or negative?
Positive.
That's right, because if you go up, it's positive. If you go right, it's positive. So my rise is 2, because I went up 2, and then my run side to side was positive 2. Now reduce that. What do you get?
You get 1.
So your slope is 1.
I put my example, my thingy is smaller, so I did 1 and 1.
Okay.
So I just still do 1.
Now look here. Kind of like what she did. Let's say I did from this dot here to this dot right here, because both of those are in the crossroads. How many places did I go up
1,
and right?
1.
So in that case, it would be 1 over 1, which would be,
1.
so the slope is 1. I have another question for you. What if I had a dot here and I wanted to go this way? Whoops.
That would be down and left.
Okay, so I went down how many places?
2,
And I went left how many places?
2,
So if I went down and left, is that positive or negative?
negative.
So then that would be down 2 would be negative 2. Left 2 would be negative 2 as well. What's negative divided by negative?
Positive.
Positive.
1.
Would you still be able to do it where it goes on the top?
What do you mean it goes on top?
Like on that one, would you still be able to make it go out? And,
These 2 dots?
yeah.
Yeah, I could go up 2 and right 2. But I wanted y'all to see that you can also go down and across.
Well,
You
it
can
could be the
go.
same thing.
It is the same thing, but that's why I want you'll see what I'm talking about. You'll eventually need to be able to go back and forth, back and forth. Yes, Whit.
Can I get graph paper?
Yes. So what's the slope of this particular line?
1.
It's 1. The slope is 1. Does everyone see that?
How do we get 9?
What's 2 divided by 2? What's
okay.
1 divided by
That's
1?
okay.
Now, anytime you if let's say they told you that the slope was 1 and graph the line. If they tell you the slope is 1 and to start graphing the line, you would want to go ahead and put it in your rise over run formula. You just stick it up, if they ever give you a slope that's a whole number, just stick a 1 underneath it so you have that rise over run. All right, let's do another one. Everyone have this down?
Mm-hmm.
Especially this red part right here?
Almost.
All right, hurry up. You got it, Whit?
Wait, do we copy down the graph or the red stuff?
You could have, but this is the important stuff right here.
I got that.
Okay, let's do another example. Now, if you want to copy this graph down, you may. It would, unless you've got graph paper, it'd be hard to show online. And you will have to use your rulers. Okay, so here's my new graph. Here's my X and here's my Y. And we need to find 2 places on the line that go through the little crossroads. See, now this one, it's not all of them, like last time, right? So if you were to really look carefully, there's one here, and there's one here. The others do not really cross through an intersection. Okay, so let's do this. There's two lines. We need to get from one line to the other. Now, remember, our thing is rise over run. So, do we go sideways first? Do we go sideways first, boys and girls? Huh? No. You always go up and down first. Always go up and down first. Always go up or down first. So, if you are going to go from, let's say, this dot right here to this dot, I'm going to go up, and I always draw like a street map to it. And then over. How many places did I go up? Raise your hand. Whit?
14.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I went up 11. Is that positive or negative?
Positive.
Because I went up. Good. So then my rise is what? Anyone?
11.
And then I went left. 1, 2, 3, 4, 5. I went left 5. So what's my run?
Negative 11 or 5.
Negative 5. Very good. So my slope is 11 over negative 5. That whole fraction is not a fraction. The whole thing is not negative, guys. You need to look at that. That negative sign goes with the 5. However, what if I started at this dot here and I went down and then over right? If I went down 11 and then right 5, what would that one be? Over positive 5. Very good. Now I want you to look at those. Both of those give you the same slope. It's either negative 11 over positive 5 or positive 11 over negative 5. It's the same slope. Same exact thing. The negative just follows a different number. Can I have a negative 11 and a negative 5 and it be the same slope? No. Because a negative over a negative gives you a positive. That would give you the wrong slope. Any questions? Do we have this down? All right. Let's move on. All right. Finding the slope without a graph. Finding the slope without a graph. Now, I just showed you how to find the slope with a graph, right? You just count up and down and sideways, right? But what if they didn't give you a graph? The formula for this, of finding the slope, is again vertical change over horizontal change. But watch what it looks like this time. The same thing as before, right? Rise over run. But here's the actual formula. y2 minus y1 over x2 minus x1.
Wouldn't that just be y1?
y2 minus y1 over x2 minus x1.
Yeah, so wouldn't that just be y1 next?
No, it would not. It would not. Taylor, let me teach first, okay? And I actually have the formula right here on this first poster. You do need to have that memorized by tomorrow. It's on the poster. But you do need to have that memorized. y2 minus y1 over x2 minus x1. Common mistake, kids always want to put the first one first. And then they get a wrong answer. So be very careful. Let's say you're given 2 points on a line. -2 and -1. And point 1 and 2. All right, I tell my students to do this all the time. You think you don't need to, but I'm telling you, it's helpful. You have 2 points, right? Underneath, put x1 and y1, x2 and y2. Because the fact that these are switched, if you put that down there, it helps to keep it in place. So if they ask you what the slope is when they give you 2 points, all you do is fit it into the formula. So if my formula is y2 minus y1, always minus, over x2 minus x1, just fill it in. What's going to come first on the top line, Joanne?
Y.
What's y2?
Y2 minus y.
Okay, so what in my points? What goes on the top line?
2.
2 minus what? -1. See how that works? You got to be careful there. y2, see, there's my y2 minus my y1. Do y'all see that?
Wait,
What?
why would y1 be?
What?
I'm confused.
What do you need to tell me?
Does it matter which way they are?
Yo, yes. That's why I said put x1 and y1 and x2 and y2 underneath your points.
But would it matter which one? Could you put x2 on the other one?
Or here?
Mhm.
As long as you put y2 also here.
Oh, okay.
Okay, so Emily, what goes on the bottom line? 1 minus what? What's x1? That's right, x1 is -2. So x2 is 1 minus x1, which is -2. Do y'all see why I have that put there? See? Do y'all have any questions as to where I got this? I can't move forward till y'all understand this part. You're just plugging in that information. This is the formula. And yes, it's confusing because the y2 and the x2 come first. But you need to put these labels underneath so you know, and go slow and steady. y2 is 2 minus, always put that minus sign, y1. y1 is negative 1. x2, here's x2, goes here, minus x1.
And how do you know which, like, y2, x2, y or x?
First point, put x1 and y1. Second point, put x2 and y2. So, negative in front of a negative gives me a, so that's 2 plus 1, and then that's 1 plus 2. So, what's 2 plus 1?
3.
And 1 plus 2?
3.
3 divided by 3 is?
1.
What's your slope?
1.
That's right. Any questions? All right, another piece of information. If your slope ever looks like this, with a 0 over a negative 4, if the 0 in numerator, you know what your answer is going to be?
0.
0. Your slope is 0. It is a horizontal line. I gave that to you already a while ago on the other page. If this time the 0 is in the denominator,
Is it vertical?
uh-huh, the answer, though, is called undefined. We don't have time for me to go into why. And like Taylor said, it is a vertical line.
Is it fine if we put negative 4?
Negative what?
4 on top of
I mean, yeah, that's fine. Any questions? That you're just going to have to memorize. Okay, let's do a couple of examples, and then I'm setting you free. As soon as everyone has this down. Y'all got it? Cecilia, are you still writing? I mean, if you got your pencil moving, I think you're still taking notes, so I don't know if I need to wait or move on.
These notes are not pretty. Mine are.
Do you have it, Joanne? Okay. Okay, so look at number 2. We're doing page 371. Page 371. Whoops. Examples. Look at number 2. I'm going to draw it for you. So this is what number 2 looks like.
No. How did you get that so perfect?
Years of practice. Okay, so this is what number 2 looks like in your book.
What video?
I've got it written there. All right, so if you look, find 2 places, and I'm saying in your book, you've got that same one. You've got to look very carefully where the line crosses the intersections of that graph. And if you look, and you can write in your book, there's a place right here and right here where it crosses the intersection. Look in your book to see if you see those places. It's where it crosses the intersection. Now, it says to find the slope. Our slope is rise over run. And let's see, Emily. Look in your book and tell me what the rise is. Do you have the same dots in your book? Do you see where the line crosses the intersection in your graph? Okay, y'all are going to be able to do this. You have to be able to look at your lines in your book and find where they cross the intersection. And this particular one, number 2, crosses there, and there. So I'm drawing my little line, my little map. So, Emily, how many places do you go up? 4. So what's your rise? And it's positive because you're going up. And Emily, what is your run? Very good. And it's positive because we went right. So that is your slope.
I got 2 of them in a different one.
No. There's for number 2, it can only be either 4 over 1 or 4.
Number 2.
Wait, what were you on?
Number 1.
Oh.
Does everyone see this? You have to find those intersections. Any questions? Either one of these, it's the same thing. All right, let's do another one. 4. Look in your book. Emily, I'm going to give you a chance to redeem yourself. Look in your book, find 2 places on the line that cross intersections. Look very carefully. 2 places that cross intersections in your graph. Look very carefully. Did you find them? Okay, so what is your rise? And what's your run? Try again. You got your rise, correct? Yes. Okay, very good. So here's one spot where it crosses the intersection, and then here's another one. There could have been more, but if you look, you go up 2, and then right 3. So your slope is 2 over 3. Now she could have gone down 2 and left 3. In that case, it would have been -2 over -3, but a negative over a negative is a? So it comes out to be the same. Any questions? Look at 6. Michael, what is your rise? Well, which is it? And then what's your run?
Also, wait, no.
What is it?
Can't find it.
Well, have you chosen 2 dots on the line? Have you marked them on the graph? Okay, so go. What's your rise?
Just 2.
Okay, what now? Go left or right, and what did you get?
-2.
So positive 2 and negative 2? You sure about that? Well, let's look. If you chose like this, if you're going, are you going down?
No, yeah.
Okay, if you're going down, that would be negative 2. But the only way to get to the next dot is to go left. So then that would be negative 2 over negative 2. What is negative over negative? Michael?
Positive. So 1.
And then 1. Or you could have done 2 dots that are closer. Up 1 and right 1. Do y'all see that? Does that make sense? All right, let's look at number 8. Cecilia, before I show 8, tell me, find 2 places on the line and tell me what the rise over run is. Y'all should be doing this too to see if she's correct. Because I'm about to set y'all free. Guys, mark in your book the 2 dots and draw these lines like this. Do what?
1.
So you got 3 over 1 on 8? You found 2 dots, right? Here's 8. Here's a dot and here's a dot. So look carefully to see what mistakes you have. Does everyone see this? You could either go up 4 and over 2, or look at here. Here's 2 dots on the line that hit those intersections. And we could go up 2 and left 1. And that'd be a negative. So then that would be 2 over negative 1, which would still give us a negative 2 divided by negative 1 is a negative 2. So either one of these would be, you could do these 2 dots, which would be positive 4 and negative 2, or positive 2 and negative 1. So if you got something different, you need to see where your mistakes are, because you got to be able to do this.
Wait, hold on. Wait, so it could have been 2 over negative 1?
This is your answer. See?
But it could also be 2.
You could have chosen, you guys listen, you choose any 2 dots on the line that cross at the intersection. So we could have chosen this dot and this dot, which would have given us 4 over negative 2. If you reduce it, you get this. Or we could have chosen 2 closer dots. Here's a dot here. Here's a dot here. You could choose any 2 dots on the line. As long as you do it correctly and then reduce it, you will always get the same answer. So see, do you see where your mistake was made? Huh? Because there's no 3, right? Could not get a 3. That's what I'm saying. If you got a 3 or anything different, then you've done something wrong. All right, let's move on. I have 2 more examples and I'm setting you free. 14.
So, let me see.
Okay, this one's using the slope formula. Find the slope given these 2 points. Here's the slope formula. And they gave us 0 and 5 and 2 and 4. Okay, now right underneath there, the x1 and y1, x2 and y2. And then we start plugging them in. Michael, what's my first line going to be? You don't have to give me the answer, just write, tell me what numbers to put up here.
4
Minus
minus 5.
-5. Very good. Emily, what do I put on the bottom row?
2 minus 0.
Very good. 2 minus 0. Excellent. Cecilia, what is 4 minus 5?
-1.
Good. And what's 2 minus 0, Michaela?
I'm still writing down the numbers. And
Okay, Aiden, what's 2 minus 0?
-2.
2 minus 0?
I have a question.
Just 2. So my slope is -1/2. Yes.
Right here under the numbers, whenever you're writing the x2, y2, could it be right here x2 and y2 and x1 and
Yes.
it could be either way?
Yes.
Okay.
Any questions about this? Y'all get this? Make sure you write underneath here. It'll help you out. Let's look at 18. This will be the last one. Again, my formula is y2 minus y1 over x2 minus x1. It would help to write the formula out each time you do it so that you don't get confused. And it also helps commit it to memory so you don't have to work so hard to remember it. If you follow my little tips, though, you should do fine. Slow and steady wins the race. Let's see, Joanne, what goes on the top line?
-1
Minus.
minus -8.
Perfect. Whit, what goes on the bottom row?
Plus 2, or 2 minus 2.
Always minus. Now, up here we have a negative in front of a negative, and that becomes a positive. Cecilia, what is -1 and +8?
7.
Perfect. 2 minus 2 is 0. What happens, Taylor, if the 0's in the denominator? What's my answer?
0. Oh wait, sorry. Undefined.
That's your slope, undefined. You are doing pages 371 to 372. You're doing numbers 1 through 7 odd. That's a 7. You're not doing number 9. You're doing 11 through 21 odd. It is due Tuesday. I mean, not Tuesday. It is due Wednesday. Your IXL is due tomorrow, Wednesday. You have a quiz tomorrow.
Tuesday, Wednesday.
All right. get started.